Yeah, welcome everybody to my little session here. Hope you have enjoyed NAV Tech Days so far. Yeah, the greatest NAV conference in the world, definitely. My name is Jörg. I'm around in the Navision world for quite some time, so probably our paths have crossed online or offline before. In the meantime, I'm a freelancer exclusively dealing with NAV and SQL performance issues and everything else that is in touch with this, supporting partners and the customers wherever it takes, whatever it takes. So performance is on our scope for today's session. And when we have to investigate performance problems and if you have to troubleshoot, we always have three areas we need to investigate. It starts with the platform, the hardware. Yeah, that's all about infrastructure. That's about server sizing, server configuration, and everything. This is the basis of the whole system, actually. The second huge area is what I call query strategy. This is all the communication that happens between NAV and SQL Server. So this is how data is stored, how data is retrieved, and everything in touch with this. And the third area, this is about blocking deadlocking. So this is conflicts between processes. This is part technical stuff. This is part logical stuff like workflow and business process design. And those of you who were attending the previous Tech Days events maybe have seen or even attended these sessions. For each area, I was presenting a very detailed session, digging into all the backgrounds, what happens behind the scenes, where problems are coming from, and how to approach this, how to resolve these problems. So please have in mind that all these sessions have been recorded, like this one, and these sessions are available for download on the Mibuso site. It's the slides and the text and the speech. So if you like, you can follow up on this and get even more details. For today's session, I don't want to be that detailed. I cannot just due to the time. So the idea of this session is to wrap up the most important things again, maybe highlight some important things, and also maybe add some more information that was in these days not that actual. What I also want to do is I want to give you lots of tools. If you're in progress of troubleshooting an NAV SQL system, yeah, you need to have some stuff to investigate the problems, to analyze the problem so that you can come up with resolutions. And with this, I want to give you some tools, show you some tools that are fairly easy to use, zero costs, even though I will present maybe some third-party tools. That's all free of charge thingies. Sometimes you have to register for the download and anything. And everything that I present, the scripts at least, I will provide on the Mibuso site for download and also on my blog space. Of course, the only thing I cannot provide, that's the third-party tools. Yeah, I'm not allowed to do that. So this is what I have in mind for today's session. Basically, if you have to proceed troubleshooting, you always have to start from the rear end, or let's say from the basis. And the basis is the platform. Yeah, the platform, that's server sizing, server configuration. This is what needs to be investigated at first and has to be fixed at first. Because on top of the platform, there's the SQL server supporting the databases. And on top of this, there's the CAL, the application. That is the thingy using all of this. And then again, what is missing on this slide, but I have to mention this again, on top of this pyramid, there's someone sitting. And this is our dear end user. And if I was rude, I would say this end user crapping down on all this. But I'm not rude, and this is public, so of course I don't say that. No, but beware of the human factor. Yeah, so human beings make mistakes, that they can do very stupid things that have severe impact on performance. But the only thing we can do about it is sufficient training, but then we are actually screwed. Also, when we look into the time it takes to apply fixes, it's actually the other way around. So, for example, if we find out that we have hardware problem, a RAM problem, so the machine just needs RAM. In this case, it's totally pointless to start changing code units or anything. So at first, we need to create to add more RAM. And the time it takes to add more RAM, that could be a few seconds in the best case. Yeah, if you have a virtual environment, you just move a slide bar from 16 GB to 32 GB. You don't even have to restart the service, and the problem is resolved. So the lower we can be in this pyramid, the more quick fixes we can apply, and the quicker we can troubleshoot. Most of the problems, and thus most of the resolutions, are actually in the center area. That's all here, what happens between application and SQL Server, all this communication. This is where 80% of all the problems are coming from, also meaning that 80% of the resolutions are in this area. So starting with the first area, platform. Maybe a little disclaimer to these slides. When I was creating these slides, I was arguing with myself if I only should present the slides that I'm really talking about. But I decided against this. So these slides contain all the information of all the prior sessions. So it's terrible, I know. So there's a lot of stuff that I do not discuss, but the idea is to give you the full enchilada. So if you like, you can follow up on this and you have all the details, all the formulas and whatever is important, all the details that have been discussed in the previous sessions. Okay, back to the platform. So platform, here the most essential thing to understand is it does not exist. There is no perfect platform. You never ever can tell if that, then do that. The problem is, or it's not necessarily a problem, but the issue is our NAVSQL system. This is not a standalone island, completely isolated from the rest of the world. So a NAVSQL system is interacting with other systems on a physical level, by shared hardware or whatever, shared system resources, or maybe even logically. So with interfaces, data exchange and stuff like this. So it's just another brick in the wall. And there are so many dependencies that it's impossible to give some guideline. If that is the case, then do that. Because there are so many questions to be asked and answered then. Yeah, like how many users, expected database size, expected growth. Are we physical, are we virtual? If we are virtual, is it Hyper-V, is it VMware? Indeed, that makes a difference. Yeah, if it's physical, do we have a ZAN? Who else is using this ZAN? Are we running 24/7? What are our demands on high availability? And. So a zillion of questions, and the answer, and the combination of answer would be always different. So it is impossible to just open a drawer and for this customer do this. It is always a very individual discussion which has to be accomplished when creating a new SQL Server system. According to discussing hardware requirements, you need to be aware of the software limitations. So have in mind that Windows and SQL Server have restrictions regarding usage of CPU and RAM. And as you see on the slide, Microsoft is playing with these limits up and down. So in terms of sizing the SQL Server properly, or the service tier, in respect of CPU and RAM, you have to make sure that the software does not spoil this thing. Yeah, so software and hardware have to match, must match. So even though there is some guidance, and you will get these best practices in the slides later, of course there's some little best practice and rule of thumbs how to size CPU, how to size RAM, disk, and everything. But at one point, you have to verify this. Especially if you're in the beginning of creating a new server, it's a lot of guessing and not knowing. So you have to somehow find out if everything is okay or if you need to change something. And here I'd like to introduce some tools to you, I hope, or maybe you know about them, which are most important to investigate the platform very simple. By the end of the day, all this platform thing is very technical, very hardware-like. And most of you are probably Navision developers, Navision consultants, so I keep this a little down to the basics. So this, what I want to show is what everyone could do. So the very first thing I want to show you is a little script. This version is taken from Paul Rendell, great guy. Read his blog, sqlskills.com. Yeah, so that's must read for SQL guys. This is a script investigating so-called SQL Server wait statistics. SQL Server is the receiving end of any performance trouble. Yeah, so this is where the performance trouble happens. So of course SQL knows about these kind of problems. So SQL Server is waiting always for anything. Yeah, nothing works infinitely fast. Of course, there's a lot of stuff that SQL Server is doing behind the scenes, and the script is hiding a lot of these nonsense counters or the unimportant counters. But indeed, with these wait statistics, we can get a glimpse on what's going on in the platform. There are counters that apply here to network, to disk, and whatever. So what I added to the script is here these little comments, so that you can read what are the figures you actually want to have here. And later on the slides, I will show you more how to interpret this data and how to work with this. But this is a fairly simple way. You just fire the script, and for those of you who are a little technical and know what happens behind the scenes, can have in Germany, there's the saying, you hear the grass growing. Yeah, and this gives the first indication for platform issues. Also for application issues, yeah, like locking and stuff like this. So this gives a very good first impression. But sooner or later, we need to have it more detailed. And here, the tool, or the tool, that is Windows Performance Monitor, perfmon.exe. This is an onboard feature of any Windows computer. And this is just a tool to record thousands of indicators that are already in the system. So whatever you install in a Windows computer, there's all kinds of health and status indicators that are already there. And perfmon is just a tool to grab this information, to record it, to display it. This is a standard feature, so I don't explain how to fill with this because that's actually well documented. The big advantage nowadays is if you have created such an assembly for Windows performance monitoring manually first time, everything is portable nowadays. So you can export this and you can import this. And what I, of course, will do is I share you my templates. So I have done the work for you already. So all you need to do is there's a thingy that's called counterlog. I apologize for the German environment, yeah. But as we have seen, most of us here are Germans, yeah. So all you need to do is you say you create a new data collector, name it, pick the right template matching to your SQL version. Is it a standard instance or a named instance? Specify the output where you want to save the file to, and that's it. Yeah, in a matter of split seconds. And this is actually a very cool assembly, and I will show you later on where this is coming from. Looking up disk, CPU, RAM, SQL counters, and a lot of stuff. This is giving a very high resolution picture, so we are recording with a 1 second interval to really see all and everything, the full truth. And it is important to record into a file. Yeah, and this is all automatically set up. So file, because in this case you can record on the customer system, on the real server, on the problematic server, and do the investigation apart from this in your back office or wherever you need. The small print of this setup is a mighty one, and it could create, depending on the location, localizations and the SQL Server version, it could create about 200 megabytes per hour. So this is nothing you should run a full day. And for that reason, there is no schedule defined. So this could be scheduled, yeah, so that you can say, start that, and then you can give a stop condition, and the stop condition is already preset to 2 hours. So this is what I recommend, to always do snapshots of a couple of hours to see what's going on here. And with this, you will be able to record in detail what's going on the machine. The result of this is very technical. Yeah, you need to have technical guys to understand this data and to interpret it. But to create the measurement, this is something that any developer could do. Yeah, you have seen it. It's importing this template so that you, as developers and consultants, you are maybe in the front, yeah, dealing with your customer. So, and if issues arise, so anyone should be able to create this measurement, and then you can provide the data to the specialists. Yeah, So once this is recorded, well, to investigate this data, this could be done manually. You open this file and then you get a lot of figures and everything, and all these best practice values, what you want to see, are documented somewhere. But it could be way, way, way better. There is a tool around, PAL, Performance Analysis of Logs. This is a tool you find on Codeplex, so it's open source, freeware, everything. And let's call it a third-party tool. But you see here from the email addresses, the third party is Microsoft. These are the guys from the platform team. Yeah, it's a kind of side project which never made it into the Windows product, so that's something they handle apart. And this PAL is something that you can use once you have done your Windows Performance Monitor measurements. You pick up the counter log here. Yeah, don't do that now. And then here you have predefined threshold files. That is XML stuff with built-in thresholds of best practice values you want to see. So you can pick, for example, your SQL Server version, and then this performance measurement will be investigated and interpreted according to these built-in thresholds. And even further up, you can export these threshold templates for Performance Monitor as templates for Perfmon. So now guess what? Where is the template coming from that I was installing right before? I have taken it from PAL, modified it, added my own magic, and this is now a measurement that is 100% compatible with the PAL thingy. So it means I can feed it to the PAL. Then you need to answer a little questionnaire output. The rest is just next. And then it starts a PowerShell magic. Yeah, PAL is just a huge PowerShell script. And the result of this is an HTML report. So here you get kind of a table of content. And now maybe switching to physical disk. Yeah, so every counter is investigated. And here in this report, the counter is explained, telling you what it is actually about. You see the thresholds that were used for the interpretation. Then we see it in a diagram, so to see, do we have exception, or what is a trend, what is an exception, or whatever. And the data is then also, we have the statistical data here to see the averages, maximum value, and whatever. And this report gives a very, very detailed insight in what's going on. Don't worry, there's a lot of red and yellow and stuff and warnings in PAL, but these colors always refer to the exceptions. Yeah, what really matters is the average. Yeah, that is the important thing. Yeah, and in this way, you're easily capable to analyze platform behavior and to document it. Yeah, that might be especially important for the partners. So if you support your customer over a period, that if you do these frequent measurements, you can see what was this month, the next month, how is it progressing, how is the system changing, so that you can react to anything weird that maybe happens. So I highly recommend to use this PAL thingy because that's really a very, very powerful tool. And I use it a lot, but then again, that's for really the hardware guys. So what I do not discuss today is, that's the slides from the last presentation. This is all these best practices about each hardware component, how to size, how to configure. On the top of all these slides, you find a table where these performance counters are mentioned. Yeah, this is the counters that are in the Windows Perfmon, and here you see the best practice values, what you want to see. And here's all kinds of rule of thumbs about sizing. Yeah, 1 CPU per 20-25 users, and so on. Again, don't have the time to repeat these details, but I left it on the slides, so if you like, you can follow up on this. Yeah, RAM here, maybe the very short version is plug in what is possible. Yeah, there's no point in saving your RAM. You never can have too much RAM. In SQL Server, it's all about RAM. Of course, it needs all to be in a reasonable, healthy state. Yeah, so if you are running Enterprise Edition, I do not recommend to plug in 4 terabytes of RAM, yeah, just because they are capable. No way. No, most divisions run in a range of 32, 64 gigabyte easily. Another thing maybe you should really print in your mind is, or other way around, no, please, you have to erase the term oversized. There is no oversizing. Oversizing does not exist. If you never can have too many resources, yeah? So that doesn't mean oversized, it means it is scalable, robust, and fault tolerant. And this is what we want to have. Yeah? There is no thing such as oversizing. And we were discussing disk. This is the trickiest part of any system, because that's the slowest part and it's the most expensive part. And here that's a big question if to use physical hardware like RAIDs. Yeah, RAIDs with all the striping and mirroring is a huge waste of storage capacity. RAID 5 we have briefly discussed, which sucks big time. Yeah, again, this is maybe something to repeat. Never ever use RAID 5 with direct attached RAID volumes, because the creation of the parity figures takes too long time. RAID 5 only uses if you have huge SAN solutions, SAN which are powerful, they're having plenty of disk, because the trick is that they are buffering the I/O with a huge RAM and VRAM cache. Yeah, so if you have SANs and loons assigned to the SQL Server, for example, actually SQL Server is talking to a RAM disk. And of course, this is fast as hell. So the limitations of a RAID 5 are bypassed in this case. Yeah, another way to bypass the limitation of these hard disks. Yeah, the problem with the hard disk is it's a spindle turning and a read-write rate moving. So this has to obey to different physical laws. Yeah, everything that happens on CPU and RAM, this is just pushing electrons. But spindle turning and everything, so here we have something like gyroscopic effects. Yeah, we have magnetism, we have inertia and stuff like this. Yeah, so totally different laws. And this is the reason why we have all this caching, our striping and whatever. Another way to overcome this is using not mechanical disk, solid state disk. Yeah, that's kind of USB stick on steroids. It's the same technology, a little more pricey and a little bit more powerful, of course. The next level of, if that isn't sufficient, well, there's a thingy we discussed also that was Fusion IO. While Fusion IO is actually just a brand name, but this means a solid state, normally the limitation of a solid state is the bus, the SAS bus, which has a throughput of 600 something megabytes. And these Fusion IO cards are plugged in via the PCI Express bus. And that one has a throughput of 1,500 megabytes. Yeah, so this is the trickiest part to discuss and the most expensive part. Yeah, just to give you some price house figures, numbers. A 400 gigabyte solid state is in a range of, depending, of 3,000 to 5,000 euros. It's a totally different range because we need to have high-end solid state disks that are really fault tolerant, not the crappy stuff that you have in your notebooks. Yeah? This cheap stuff, if you don't know what I'm talking about, please Google solid state blackout. This is what will happen to the cheap disk, and this must not happen to database drives. No blackout. Yeah, this is why this is expensive. And for example, Fusion IO cards, one of my customers recently bought some, one card, 2 terabyte storage, 40,000 euros. Yeah, but of course, the IO is just playing rock and roll, of course. So all these best practices around a disk, what to put where, is all listed here. Yeah. One thing I'd like to focus on a little bit, because I think that was a little short in the original presentation. Something about this dynamic service tiers. There's always the question, how many service tiers do you need? How many users can a service tier take? Well, basically nowadays, a service tier is highly scalable. Yeah, it's 64-bit, it can use CPU, it can use RAM. So basically, almost infinitely many users you can put on one single service. But if you should do this is another question. So from the sizing formulas, they are listed here. So that's no big thing. But there is some, I would call it a fairy tale around in the internet. And I hope you never came across this so far, but for those of you, there's some cowboy advice telling you, okay, you should have 150 users on a service tier, and you only need 2 CPU for that. And if you really believe this, then you didn't hear the shop. This is a terrible misconception. Unfortunately, this is not fully wrong, but it does not tell the full truth. With a service tier, you have to have in mind, we have 2 lines of communication. We have the line from the service tier to the role-tailored client, to the front end. And here on the service tier, we have a setting that is the maximum concurrent sessions. No, the maximum connections, sorry. Maximum connections is called. The default value of this is 150. So by default, we can connect 150 role-tailored clients, or clients at all, to one service tier. If you try to connect user number 151, then you get a runtime error, you get an error. So this is the first line, yeah, and 150 users for a service tier, that's fair enough. So now we have to be aware of, we have a second communication line from the service tier to the SQL server. And this is defined by a setting that's called maximum concurrent calls. And here the default value is 40. So that means, yes, you can connect 150 users to one service tier, but actually only 40 will work. Yeah, all the remaining 110 users will be queued in the connection pool of the service tier. Yeah, this is like Lufthansa selling you 150 tickets, but you only have 40 seats. Someone will have to wait. But unlike Lufthansa, you don't get a €100 voucher if you take the next flight. Yeah, and then of course, a rule of thumb for CPU is 1 core per 20-25 users. Yes, of course, as long as just 40 users are working, 2 CPU are okay. But I guess that if you have 150 users connected to the service, you want to have 150 users working. So you need to increase this max concurrent thingy here. This needs to be equal to the real number of users connected. And according to this, the number of CPU needs to be sized. So what I suggest or highly recommend is to have at least 2 service tiers, just for fault tolerance, so that you can balance. So because for sure you experience this, service tiers tend to crash once in a while, just for no obvious reason. Yeah, and so if one service goes down, you have another one up running where you can route the users. If you just have one single service tier and this goes down, the whole company is done. Why we talk about crashes? Well, you have to be frank, but it is the case, the older a service tier built, the crappier it is. So if you have very old versions, you will experience terrible things. Yeah, unexpected crashes. You can see the mother of all memory leaks and stuff like this. So the service tier builds, they start to get stable springtime this year. So you should not use any build, any CU level older than February this year. Yeah, these things suck. And there's nothing you can do about but patching and going to the next, to a recent cumulative update level. Yeah, another thing I'd like to highlight here is this async network I/O. This is a counter from the wait statistic. Because this is something you always have to discuss with the real SQL DBAs who have idea about SQL but no idea about NAV. Async network I/O means that a SQL server has shipped some data to a counterpart, to a client, NAV service tier whatsoever. And then SQL just waits for this client to confirm the reception of the data. SQL Server just wants to know, did you get it? So, and if this async network I/O wait statistic is in the high ranks, this could indicate 2 problems. First problem is we have a network problem. So really that we have broken network adapters, switches wrong or whatever. So really a network problem. And the second reason is, so guess what applies to our world? And I'm quoting here from a SQL blog. The second reason is that the application is just programmed in a shitty way. That's not my words, yeah. So I wouldn't say that Navision is programmed in a shitty way. No. The reason is this, since the NAV 2013, this async network I/O will always be in the top ranks. And an original SQL DBA will panic, yeah? They will start to tear the cables and then disembowel the network and whatever. No, this is should we call it a feature? This is the way how the service tier is running. We have a communication way from service tier to SQL Server, which is called MARS, multiple active result sets. The idea is that the service tier is caching some data. Yeah, so that the data is once queried from SQL Server, and then this same data could be read from all other users on the same service tier. That is basically the idea of this MARS. So what now happens is, in this MARS thingy, if you open a page is firing a select top 50 query to the SQL Server. So yes, SQL Server will retrieve 50 records as fast as possible and send it to the service tier. But now, unluckily, the page cannot display 50 records, just because of the size of it. So probably the page only displays 20 records. It means that the remaining 30 records are cached on the service tier. And while these records are in the cache, SQL, the service tier does not confirm the reception of the data. Yeah, SQL shipped 50 data and asking Navision, hey, did you get it? And Navision said, wait, I have to render it to my client. No, wait. And while this happens, async network I/O is counting up. Yeah, so, but in reality, the data is there already. Yeah, it's just a matter of how the service tier responds to the SQL Server. So async network I/O is not necessarily a problem in our world. Yeah, but you have to know this, because in the rest of the non-NAV SQL world, this is a problem. Yeah, else it would be too easy. Yeah, another word, a little bit about virtualization, because there's also some misconception around. Some people obviously think that a hypervisor software is a magical software magically creating CPU and RAM, which is not the case. Yeah, we're not living in Ivory Tower, Copenhagen. No. So the story is this. A hypervisor is only used to manage software. Yeah, this is the idea of a virtualization. So you have a finite amount of system resources, speaking of RAM and CPU, and the hypervisor is supposed to handle this, to manage this. So that means what you should not do, you should not sell more resources than you actually have. Means, for example, a host, if a host has 32 CPUs, then you can create, for example, 2 servers, each using 16 CPU, totaling to 32. Or you create 4, each 8 CPU, totaling to 32. Or you create 16, 8, 8, totaling to 32 CPU. You get my drift. Yeah, so whatever you do, whatever servers you create, but you never exceed the actual number of physical resources. If you do that, the host is overbooked. And then again, it's like Lufthansa selling more tickets than they have seats. Somebody will have to wait, and performance will drastically be decreased. So for a high-performance system, you have to make sure that the hypervisor, the host, really fulfills at 100% the hardware requirement of the SQL Server or maybe the service tier. Yeah, so this could be handled depending on the hypervisor software with a static CPU assignment, 100% reservation and stuff like this. So never ever overbook a virtual host. Another tripwire that you could come across is if you run virtualization in a cluster. So you have multiple hosts underneath one hypervisor. So the idea is that you have a virtual server, and if you need to move it, for whatever reason, you can move it easily from one host to the other on the fly and everything. So this is a very cool feature for fault tolerance, for high availability. But the small print is, if you have such a cluster, you must make sure that all these hosts have identical hardware specifications. Especially, they need to have identical CPU specifications. So down to the clock speed, they need to have identical type and clock speed and whatever. Because if that is not the case, then hypervisor could switch into an emulation mode. The hypervisor will emulate the CPU for the server, for the virtual server, matching to the lowest specification in the cluster. Because that is the lowest specification could run on any host, not the other way around. And this emulated mode sucks big time. Yeah, totally done. What the symptom of this will be, if you check it in SQL Server, that you will see a delay between each query execution from around about half a second. And of course, you can imagine one query pause for 500 milliseconds, then the next query. This is terrible. Yeah, so you have to make sure that if you run these kind of clusters, that they have the same powerful resources, else you will encounter very weird things. Okay, so but that's it about platform and hardware. So now I'd like to discuss or highlight some things in this query strategy context. This is actually the most important part for performance troubleshooting, because in this area, most of the problems are coming from, and it also means that here we have most of the resolutions. When it's about query strategy, it's important to understand how SQL Server is storing data and how it is retrieving data. In SQL Server, everything is about indexes. Imagine this. You have a huge warehouse. This is your table. And in this warehouse, you have thousands of drawers. This is your data pages. And in each drawer, you have some pencils. That is your records. So now you are a SQL Server, and you enter this huge warehouse. And now your challenge is you get a query to process. Give me all the pencils, color equal red. Well, what are you doing? Yeah, so what? Big warehouse, thousands of drawers, so what you can do, the only chance you have is you open every single bloody drawer and check if there's a red pencil. And of course, this takes forever. Yeah, taking a long time, causing system resource and so on. So to process these queries fast, SQL Server needs pointers, indexes that point to the result sets, to the data. Yeah, so what you need is when you enter the warehouse, there should be some guy around where you can go, hey guy, can you tell me where are the red pencils? Yeah, and then this index guy tell you, okay, this is in this drawer, in this drawer, in that drawer. And then you can quickly seek out these records and fetch it and yeah, do your query, so to speak. And in SQL Server, it's all about these indexes. So once upon a time, we were explaining how this is built up. We have different types of indexes. Again, I don't repeat this. Yeah, and here we have two ways of using these tables / indexes. We have one fast way to retrieve data. This is the seek. Yeah, this is when you're directly pointing to the data. And the slower way actually will happen if something weird happens, is to sequentially read an index. This is like opening any bloody drawer. So this actually implies two challenges for us as developers. The first challenge is we have to make sure that SQL Server has the right indexes. This is the first challenge. And the second challenge is we need to make sure that SQL Server is able to use these indexes in a proper way. And this is how we program, which methods we use, yeah, find set, find first, and whatever. So the first challenge is a little bit supported by Navision itself, because whatever we create as a key corresponds automatically as an index on a SQL site. So we have a decent set of indexes for a start. But due to the way how our keys are designed, they are actually quite inefficient for SQL Server. So the reason is Navision is doing a very, very basic indexing. SQL Server has way more features to create smart indexes, using features like included columns, filtered indexes, whatever. And Navision is only using a fraction of these capabilities. So by the end of the day, we end up in a situation that many of these indexes that are already created by Navision are not used. SQL Server cannot use them because they have some nonsense information. Yeah? It's like SQL entering the warehouse. Hey guy, can you tell me where is the red pencils? And this guy says, no, I have no idea about the color, but I can tell you which wood they are made from. And SQL says, yeah, thank you very much. Here's the middle finger. So I start to open the drawers again. Yeah. So this is what we have. So that means a lot of indexes are missing. So in the second challenge of how the indexes can be used or not, this is actually which methods we use for the programming. And here the huge challenge we have is that we have two different worlds. We have the old world that is everything until Navision 2009 release 2. And the new world starting with NAV 2013. The problem is in the old world we have a big issue that's called dynamic cursors. Some of these commands can create these dynamic cursors, and by the end of the day, a dynamic cursor prevents SQL Server to pick the right index for whatever reason I keep secret today. Yeah, these dynamic cursors suck big time, and they are often responsible for huge performance problems. This has been understood by Microsoft. Yeah, all this cursor stuff has been removed from 2013 on. So that means, yes, there is still a difference between the commands. And if you talk about the commands, I think find first, find last, and is empty, that's pretty clear. Yeah, that you find first if you want to process only the first record, find last if you only want to process the last record, is empty if you only want to check if there's something. So this is pretty obvious. No, the challenge always is to use find minus find set. Yeah, which one is the better one? And again, to keep a long story short, I recommend to use the find set as long as possible. So so far that works good for me. Again, the details have been discussed on other places. Yeah, so these are the two challenges we have to face. But it is actually pretty pointless. To open the code units and now try to change any kind of code and find commands and so on, just without even knowing if there's a problem coming from. So at first we need to see the problem, and then we can react on this. And this is what I'd like to show you, how you can find out, how can you learn about these kind of query strategy related problems. So the best tool of choice is another onboard feature, that's the SQL Profiler. SQL Profiler is a kind of server monitor which is able to record everything that happens on the SQL server. And then again, there's hundreds of events that could be monitored, and it's well documented because it's a standard thingy. And as it is with all the other things, once you have created your assembly, you can create templates, it's portable, and of course I share my templates with you if you like. So here I have all kinds of templates here, take this one, which is just a pre-selection of events that are feasible for troubleshooting purposes. So what we can do with this, we can save the output to a file, which is highly recommended. Yeah, you can also trace in a table, but I'd rather not do that because if it's a file, it's portable. If you save the output into a table, this is additional workload to the SQL server. So you might end up in a situation where you are profiling the problem that your profiling creates. Yeah, so that is not the point. Yeah, and with this, actually, we are able to now see what's going on in the system. So what I have to do now is something that you, in real life, please never ever do. Just firing up Profiler. Profiler always needs to be filtered to reduce the number of events it is recording. If you use Profiler in an unfiltered way, it will kill the disk. Profiler has some decent costs, and if you just run it on the GUI, it will save all output in a temporary file, usually on a C drive. And if you don't watch it, and Navision could fire 5,000 queries per second, so this file is immensely growing. Yeah, so suddenly you kill the disk and have another problem. Just for demo, I'm doing this here. And then basically we could do some Navision processes, just to record what's going on. And here what is important to have in mind, what we have in the debugger today is a SQL trace feature. So normally, Navision just sends the statements. It's firing the statement, the queries to the SQL server, and we have no clue about the Navision context. But with this enabling the SQL trace feature, the service tier will also send the so-called call stack to the SQL server. And this is what I'd like to do just to demonstrate. And now I have a little code unit here that is just creating sales and posting this stuff. Where are we? So just stop it here maybe. So here we see all the queries fired to the SQL server. We can see the pressure they cause. Yeah, the number of reads is the number of data pages. If you multiply this figure with 8 kilobytes, you know how much memory is consumed. We see the CPU time, the duration in milliseconds. So we see which queries are expensive. Yeah, which queries causing bad performance. The call stack is here sent as a separate batch. And this is actually a cool thing, because the problem is with all these statements, we don't have any user delegation anymore. So we cannot identify a single user on a SQL from SQL perspective. All users use the same login of the service tier. So this is a problem to see who has executed this query. When enabling the call stack with the SQL trace feature, here we can see the user, yeah, the human being behind this login. Yeah, and we see which is the code unit this code is coming from, which line of code, which function, and so on. So basically the idea here is pretty cool. So to combine the SQL world with an NAV world. So, and if we have this kind of traces, yeah, so I was recording now for just a couple of seconds, and you see here I have 78,000 lines recorded. And this is just a single session creating orders and posting them. Yeah, imagine what happens with 150 concurrent users. Yeah, this kills the profiler and the system. So now, yes, I am able basically to record queries and the call stack. But now, as we see here, this is, even though this is Kronos, most of the queries have hardly any execution time. So we see that the duration in the CPU time is 0. That means we're not talking about milliseconds, we talk about microseconds. Yeah, fast as hell. So, and I don't want to see what's good. I want to see the expensive queries. I want to see what's wrong. Yeah, hell spells. Technically, we could accomplish this if we do a profiler tracing, where we, for example, we can filter on the number of reads that indicates the memory consumption. And or we can filter maybe on the duration, that we only want to see queries that take longer than 20 milliseconds. So we want to see what's expensive, what is causing performance issues. Now the problem is, if we start to filter on these values, say bye-bye to the call stack. Because the call stack is not a query at all, it's just a comment, and this always has 0 reads and 0 CPU and stuff. So if you start to filter the tracing, the call stack is filtered out, it's gone. Yeah, thank you very much. So, so this is the challenge we have, yeah? Either we trace unfiltered, causing one problem by immense, huge profiler traces, or we filter and then we don't see the call stack. It's a little pity. But anyway, for now. Once we have these traces recorded to a file, then it's actually very easy to investigate this. Now it was 78,000 lines, so nobody wants to manually browse through 78,000 lines and try to find out what's wrong and what's good and whatever. No. All this kind of traces can be investigated. Yeah? So this is plain, simple SQL code, or maybe not so simple SQL code, but no rocket science. Yeah, and this kind of scripts can read these trace files, group the queries, and then they can tell you what happens, how often, how long does it take, so that you can decide, yes, this is a frequently or oftenly occurring problem, this is something you want to fix, this is something you want to ignore. Yeah, this is all the idea. So just to group the data, and then you can come up with resolutions. So this is let's say a generic script to investigate these trace files. But there is also another one you should know. This has been published by Microsoft. This is a script that also investigates these traces, but this one combines the call stack with the SQL statement. Yeah, and this is actually very cool. So you have the SQL problem with all the resource consumption, the duration, the occurrence, and everything, and you have the link to the Navision world. So yes, that would be actually pretty cool, but the cost for creating this call stack trace is pretty high. And for this reason, it is very tricky to isolate problems in a service tier world now. Yeah, because there's no more user delegation. So what I suggest, or highly recommend actually, is you should always have a separate service tier instance only for debugging purposes. And this debug instance should use a login apart from any other login, like NAV debug. Because then if you want to investigate all kinds of problems, then you can just, and sometimes you have to do this not on a test box, but you want to do this in a real life scenario, on the real hardware, on the real database. Yeah, but this way you can just connect to the debug server, and then you can isolate a problem and then look at it. And then you can use the profiler, maybe with the SQL trace and everything, but then you have actually a kind of pre-filtered look. Yeah, so isolating the problem. This is a tricky thing, and it's easier if you have a special service tier for this. And for another reason, because you need to change some setting, or you should change some setting for this debug instance, but I show you why and how. Yeah, so with these traces, we can do a lot. But now, well, we see the problem and what is the resolution. Yeah, should you do? Should you change some code? Should you change indexes? Should you add indexes? Well, so basically most of the stuff really is indeed due to missing indexes. And this is something that you have to learn. Yeah, so creating indexes for query problems is not rocket science. Yeah, this is done every day by thousands of DBA in the world, and you can do this, of course. No, but if you're not familiar with this SQL magic, yeah, and so on. There's other stuff around. There we have a script that works independently from profiler traces. Whatever you execute on SQL Server is automatically cached on the service tier, on the SQL Server. Yeah, it has a procedure cache. So it memorizes everything it has executed. So there are already the expensive queries. And with this script, we're just looking them up. So this is a script looking into the procedure cache, and here I can see similar things. Yeah, all the queries. It's always the same story. We just want to know what happens, how often, and how many resources does it consume, what's the pressure on the memory, what is the duration, the CPU time. Yeah, and with this information, then we can work. Yeah, we know what happens, how often, what do we have to fix, or maybe not. And if you have such a thingy here, you will often find kind of these advices. Missing indexes. This is the Kronos. In a real life, you will see that maybe 80% of all the problematic queries are just because of missing indexes. Yeah, again, SQL Server is a smart thingy. Imagine this, SQL Server is entering the warehouse, yeah, still looking for the red pencils. But now there is no index. Yeah, SQL Server enters the warehouse. I have to ask someone about red pencils. Oh shit, nobody here. Okay, start to open the drawers. But while doing open the drawers, SQL Server says, oh shit, I could avoid this if there was a bloody guy telling me about the colors of the pencils. Yeah, and this is how these missing index proposals are created. SQL Server is forced to do something stupid, but it knows, in many cases, how to resolve it. So we see that it is just because of a missing index. There is no need to change find methods and changing code units or whatever. It's just adding an index. And on the lower section here of this script, I'm just looking up all these proposals. Yeah? And we can see how often has this index been proposed. What is the impact of an index? Here I'm filtering only on indexes impact greater 90. Yeah, that means like in this case here, SQL Server has proposed for 84 times just a few minutes ago, give me a bloody index on this table with these fields. And if you do so, the probability is at 96.82% that the problem will be resolved. Or in other terms, give me that index, problem gone. Yeah? So all we need to do is to pick up these index proposals and provide these indexes. And this could be done in Management Studio. You don't have to fiddle with NAV. Of course, this has some challenges, yeah, and a lot of small print. This is something that you have to learn. never ever copy paste these kind of proposals and execute this. This will raise hell. There's a lot of crap proposed here. Yeah, it's just a stupid machine generated thingies. Of course, there's a lot of issues, let's say. It all needs to be verified by a human being. So, but once you have learned to interpret this and to clean up these proposals, yeah, if you could get rid of all the dust and dirt around this, then you have here really, really grains of gold where you can apply quick fixes. Yep, because these indexes, you can create them on the fly while the users are working. The worst thing that happens is that the users get blocked for the duration an index is created. So in a large table, so maybe you do it off business hours. Yeah, but this is a huge advantage. You don't have to fiddle with the Navision application. Yeah, like you have partner add-ons. So do you really want, are you allowed to change keys? Yeah? A key would also create an index, but are you allowed and willing to change some tables? What are you doing if an object update is coming from? Yeah, so with this you can work independently from the application and you can work fast. Again, this is something that you need to learn. Yeah, yesterday we spent a full day on discussing this thoroughly. Yeah, so the problem we have is this kind of indexing is done on the whole planet by thousands of DBAs every day. We just have some specialties. We have some special rules, and I have a slide where all these special rules are listed. Yeah, so that we never ever name an index dollar something. Yeah, we have to be apart from the Navision naming. Never ever touch a standard Navision index in Management Studio. Yeah, that will be a real power. But if you have learned this, then you have a very, very powerful thing to quickly fix problems. So, where is it? If you do this kind of troubleshooting, sooner or later you will, with Navision 2013, you will find some expensive queries that look like this, if you do this profiler tracing or whatever. And you see it maybe here from the scroll bar. It's a pretty long query. This query has more than 18,000 characters. And this has been fetched from a real-life scenario, so this is not a fake thingy. So now tell me what's wrong with this query. So, any ideas? Yeah? No. So this query, it's called a smart query, yeah? And this is actually an insult because this is everything but smart. Okay, anyway. So now, the problem is this is unreadable. You have no idea how, what's going on, what is the query doing? Yeah? And now if you start to format this manually with every keyword, you do a line break, so you're screwed. Yeah? It takes forever. So what I recommend to use is, and there are a lot of refactoring tools around, add-ins for Management Studio that can do some formatting. And the thing that I prefer to use is Apex SQL Refactor. This is a freeware tool. You have to register for a download, and this is a plugin for Management Studio. And with this, you can define how to line break, how to indent, and whatsoever. And if you run this Apex thingy, what it will do is transform this query into this. And now it is readable. By the way, what we are now doing is this is black belt troubleshooting indexing. Yeah, so this is really annoying. So now we have this query having 16 subselects. How come? Yeah, in the old days, when you open a card or something, with the old way to create flow fields, this was firing a half a dozen of queries to the SQL server. Each flow field has been calculated by queried by a separate query. Nowadays, if you open a page, all flow fields displayed, all subpages, all fact boxes, whatever is placed on the page, all this is created into one single query, which is called smart query. So any flow field, and this is one huge select with, in this case, 16 subselects. And now the problem is, if there is just one subselect screwing up, the whole page is done sometimes. I had a case where we had an item page, and I'm not lying here, this item page took 9 minutes. Hell on earth. So what you need to do in this kind of scenario? In this case, what you need to see is the execution plan. The execution plan could be looked up here from these links here. But I have already prepared this. So those of you who have seen execution plans before, yeah, now this is a plan for men. Yeah, this is for the big guys, not the sissy plans we have in the old days, no way. Yeah, so this is how an execution plan looks like. So, smart query. So, what is the next step? If you have this, now you have to find high-cost operators. You need to find operators here that have exceptional high CPU load, or operators that do sequential reading, yeah, scanning indexes. And this is what you have to find in these monster plans, and sooner or later you will end up here. Yeah, here we have such a high-cost exception. So yes, this is probably the thing screwing up, causing all the trouble. So now with going with the mouse over, you can see the table names, the aliases. Here's something about the quantity, the filter, whatever. So and with this knowledge, now you can go into our query. There's another. And in this case, it is this subselect. This is the problem, the troublemaker. And then again, the only thing that is necessary, this select is insufficiently supported by there's no index, to make a long story short. Yeah, so by just adding an index, obeying all these rules with a naming convention and whatever, just adding this index made a difference between hell and paradise. Yeah, and the same was with this item page of 9 minutes. It was just one single index missing. Adding this index back to opening this page in less than a second. So by the end of the day, it all boils down to the same. So we have expensive queries, pressure on the CPU, taking forever, just requiring a bloody index. This is what most of the trouble is boiling down to. But the problem now is with these smart queries, and we'll have a lot of these problems, it takes forever to investigate this. Yeah, with all the execution plans and whatever. And this is why I would suggest this. I have to go back a little bit here to my service tier. You should have your debug instance. In this debug instance, you can disable Smart SQL. So it has been introduced in the more or less recent hotfixes, I think middle of this year. Around. So, and if you disable smart query, you don't get these monster queries. In this case, each subselect is filed separately, like in the old days. Yeah, basically, smart query is a good idea because the idea is to reduce the traffic between service tier and SQL server. But if you have a problem coming up, if opening a page takes forever, then route this user to the debug instance, which is not doing smart SQL, and then you will see instantly which select is screwing up. You don't have to do all this filling with these monster execution plans and everything. Yeah, this is terrible and time consuming. So this is what I highly recommend. Have your own debug instance without using Smart SQL. Oops. Here we are. Okay. So all these rules, again, they are listed on the slides, all the do's and don'ts, how to do this, whatever I now briefly discussed to follow up for you. This smart query thingy. So, the third area, blocking and deadlocking. Yeah, I have mixed feeling about this, but okay, anyway. The most important thing to understand is that locking is just an administration mechanism. SQL Server must know at any given point in time who is reading data, who is writing data. And it needs to know this to maintain the data integrity. And this mechanism to manage all this is called locking. A lock is nothing but a status information for a system resource, for a record. So that SQL Server knows someone is reading this, someone is writing this. So this is not a problem at all. Locking is mandatory, it's necessary. The mechanisms that happen in the rear end in SQL Server are quite complex. Yeah, we have different lock modes, we have different levels. It's an escalating locking mechanism. Yeah, so SQL Server, yes, could start row locking. It will start row locking if possible, but SQL Server could decide differently. SQL Server could decide to instantly hard lock a table. Yeah, or it could start row locking and suddenly replace row locks with a table lock and stuff like this. And besides this, there are so-called transaction isolation levels. Yeah, so this is all very sounds complicated. It is, but the advantage is that this complexity actually means precision. So technically, SQL Server is capable to precisely lock resources down that are really necessary to lock. If you remember the old Seaside server, yeah, the native one, in the old native server, the only thing we had was a digital locking, yeah, table lock on off. That was the only thing it could do. So locking itself is not a problem. Yeah, so here I'm explaining the modes and what they actually mean. But then again, the lock itself is not a problem. The problem occurs if we end up in this matrix of doom. Yeah, this is kind of a simplified decision matrix of SQL Server. For example, if we have two users at the same time trying to update one. So the first user tries to update, and if nothing happens, so if the resource is shared, the user gets the update lock granted and is allowed to change a record, yeah, to change the address of a customer record. So now if a second user tries to change this customer at the same time, it will also ask for an update lock, and SQL Server will look up, sorry, we have already an update lock here. No, you are not allowed to proceed your change. Yeah, so the lock actually turned into a block. Yeah, one user has to wait. But that the block is happening is not an error, it's not a malfunction. Yeah, it must happen, this kind of blocking, because it's an integrity protection. So this is not the problem, and this is something we never ever can get rid of. What is the problem is the circumstances that lead into this blocking situation. Yeah, so, and with this, if we talk about this, the circumstances, we have to talk about probability. Yeah, how likely is it that you have two processes at the same time changing the same customer record and so on? And here, what spoils all this probability is this locking escalation. Yeah, because the higher SQL Server escalates, the higher is the probability to get blocked. Yeah, so the risk of having conflicts on a row level is very small. But if you were starting to hard lock, for example, the whole database, of course that's maximum damage, there's single user mode. So the higher it escalates, the more critical it gets. So here it is important to remember that we can influence this lock escalation by forcing row locking. Yeah, this is something we can do in the old days up to Navision 2009. So with forced row locking, we minimize the probability of having conflicts because we tell SQL Server you must start row locking and you remain as long as possible on a row lock level. We suppress the lock escalation. The cost for it is we consume more memory. Yeah, this is forced row locking uses up more memory. And so we are back to server sizing. Did I ever mention that you cannot have enough RAM? Yeah, RAM. Oh, all right. So the more RAM, the fail-safer this works. According to my experiences, you can use always row lock safely if you have at least 16 gigabytes. In some cases, even less, 8 gigabyte and up. This is not available anymore in SQL Server 2000, in Navision 2013, sorry. So when Microsoft said they're removing this feature because the RAM could be used better. Some people had doubts, and we were right. So what we see now in NAV 2013 is a lot of escalated blocks, of escalated locks. So we see a lot of table locks, page lock, and all that stuff. This is coming from this escalation. But nowadays, there's no more way to handle this with this row lock thingy. But there's a plan B. There's a trace flag around. There's 1224. This is a tracing. If this is enabled, you switch the whole server instance in a mode like forced row locking. You also suppress the lock escalation, with the same implications like this other row locking. So this could help NAV 2014 if you have these escalated locks and blocks. But then again, trace flags are working on a global level, so you have to be aware what else is using the same server, because what is medicine for NAV could be poison for another application, like business intelligence stuff. BI stuff, never ever use this. And also never ever use the old one, 12.11, which you always also still find in the internet. Internet never forgets, but this kills the machine. With 12.11, with the old one, you can risk that you completely use all the memory for locking. And then the server just says, well, bye-bye. Yeah, these isolation levels, that's a little complicated. And this actually, in the old days, raised some severe issues. The way of how hard locks are established in NAV. And what has been one of the most promoted improvements with NAV 2013 was that the isolation level that is now used for hard locks is set to repeatable read. In the old days, it was serializable, which is raising some hell, so-called range locks, actually, which really cause a lot of trouble. And just changing this isolation level to repeatable read dramatically improved the behavior according to locking and blocking. So this was one of the most promoted things where they said, oh, we are locking 90% less and everything and so on. So this has been very, very promoted. And indeed, this really, really is helping. And what we can say that in NAV 2013, we see way less blocks than in the old days. So what, unfortunately, has been a little under-promoted is that the old Navision versions can also use repeatable read isolation. You just have to tell it. And unfortunately, there is no GUI switch for this, no flag or anything you can use. You have, if you didn't come across this knowledge base article explaining this, you never, ever would see this. There's some system table DB property, and there's a magic switch diagnostics. The default value is 0. So, and if you add this magic key here, then your Navision, the old Navision, also could switch into repeatable read isolation mode. If you have these builds that are listed here. And just by using this repeatable read isolation, you get rid of half of the number of blocks, often even more. So because the old way of how Navision is locking is stupid, doing terrible things. So those of you running in the old world, this is something I highly recommend to check this out. This is something I will ignore. Sooner or later, we will face blocks, because again, this is integrity protection, and it depends on the business processes actually if we end up in a blocking situation. Unfortunately, Navision has a lot of single points of failure. Just the way of how ledger entry tables are numbered. When you increase, if you add a new item ledger entry and the new entry number is created, it's always the same algorithm, lock the last record in this table and increase the number by 1. And if you have 2 parallel postings, they really try to hard lock the very last record in the same table, so really meaning the same record, and they are ending up in a block, of course. And NAV has a lot of this single points of failures, and there's often hardly a way to get around this. So yes, sooner or later we will have blocks. So, and now I will create some blocks. So I start my first session. The first session will hard lock the sales header. And then I'm starting a second session with a separate code unit. And this will lock the purchase header. So go to my first session. So now I'm locking the sales header. So again, it's really a lock, nothing happened, no problem at all, not yet. My second session now is locking the purchase header. So far, everything is cool for both sessions. So now, if the first session, which already locked the sales header, now it tries to lock the purchase header of the second session. Now I have a block. Yeah, because the purchase header is already locked by the other session. I try to also establish a lock, and SQL Server behaves impolite, giving me the middle finger. So this is a block. Okay, so again, it's SQL Server handling all this, and I'd like to introduce a way that I use to investigate or to detect these blocks, which basically is a very simple way. We can create alerts as event triggers. Yeah, there is, again, it's a performance counter that is already there. So, of course, the system realizes there's something blocked. And what I do now is, in case of such an event, I am firing up a corresponding job, and this job runs a store procedure that collects all the information about a block and saves it to a table. Yeah, so that's a fairly simple event-triggered way to automatically record blocks. So when it's happening, it's automatically written into a table. And this information could be investigated anytime. In this download package, maybe have a quick look at what I provide. So for those of you who want this, you find all the scripts even numbered so that you know in which sequence to execute with, and then you can establish this easily, even with a small SQL knowledge. Yeah, so that's, again, it's no rocket science here. Yeah, so when it is recorded, then I just can, whenever I find the right script, this one here, I can look it up in my recorder. This is a lot of stuff from the days before. And then I can see, again, what's happening, how often. For me, it's always important to count the problem, to see what's important, what you want to fix, what do you want to ignore or postpone. And then you can group the data however you like. This is just templates to see which table is locked how often, all the details, which queries, blocks per hour, blocks per day, whatever you want to do. So basically, it's easy. Now the extra challenge that we have to face is, in our dear NAV 2013 world, we don't have a user delegation. So if we have a block, like in my situation, what we will record is always service tier is blocked by service tier. Thank you very much. But then again, blocking is usually about business process. It's the circumstances, it's the workflow leading into this matrix of doom. So we need to have a relation to the business process. So the least thing we need to know actually is the username. Yeah? Somebody we can ask, hey, what have you done when you were blocked? Yeah? Or the culprit causing these blocks. So without knowing the user, it's a really tricky challenge to find any clue about the workflow, about these circumstances. So this is a big problem we have with NAV 2013, but there is a way around this. So what we can do is, again, running profiler traces, and this also could be done automatically. This one here. So a prerequisite is I enable the SQL trace feature, yeah, so that the call stack is sent to the SQL server. And then I'm filtering on a special string combination and save it to file. So this is actually just a trace on the call stack. So and if we have this, yeah, this is just such an example call stack trace. If this is loaded into this little code here, yeah, that's all a little SQL magic. I can parse this string, and then we get a list of which SPID, the process ID, has been which user at what time. Yeah, this is the information we need. So I know that Stryk has been spit 57 at this time. So all these block recordings, of course, what I can record is the SP IDs. Yeah, so I have the SP IDs and I have the time. So if I have both this SQL tracing thingy and the block recordings, I can combine this. So with another SQL magic, it's just huge select statements, nothing else. So I can marry this. Yeah, I have on my block recordings, recording SPID and everything. And here I see a login as SQL service, but now I know which human being it is. Is it Smith? Is it Taylor? Is it Jörg? Whoever. Yeah, and then with this, again, we get a clue maybe to the business process. So yes, we can do this. Yes, we can find out which users are involved in these blocks. Again, the downside is the prerequisite or requirement is to have this SQL trace up running. And this, again, causes a hell of a load. So it is impossible to run this throughout the whole day on all service tiers. Yeah, you have to enable SQL trace on all services you have up running. Yeah, so I give it to you. No warranty, no guarantee, no support, no nothing. If you use it, blame yourself. No, but you can use it on a very focused scenario, on isolated issues when you really want to see what's going on. So what I suggest is if you start this tracing, always have a close eye on the size of the traced files so that you can cancel all this if it's exceeding a certain space. Yeah, not killing your disks. Yeah, and this way, we can keep track about blocks. We know what's going on and come up with resolutions. At this point, I will make a little excursion to some other nice tool we have. You probably know, activity monitor. Yeah, this kind of basic thingy. We see CPU, a little bit of this and that. Also here you could see which processes are blocked and whatever. There's a neat tool around. So I don't know if it's really important, but just for the fun of it. It's from IDERA SQL check, freeware thingy. This is a kind of activity monitor plus. Yeah. So you can also see all kinds of statistics and everything. But what I find quite funny is the way how they're displaying the processes. Yeah, so there's a legend where you can see what is done. And the nice thing is you can see these blocked processes. Yeah, who is blocking whom, who against whom. Yeah, so visualizing the data, very easy. With this thing, you could actually monitor multiple server instances if you have. Yeah, so, but you don't want to see that with 150 users. Yeah, so just a little side task. Yeah, the queen of blocks is actually our dear deadlock. And a deadlock is a situation when we have two processes in a kind of crossover blocking situation. So everyone is a victim and culprit of the opposite one, crossover block. And to learn about this kind of problems, again, basically, Profiler will help. Because there is an event, that's the deadlock graph. So whenever a deadlock happens, SQL Server could create these graphs, and this is just XML information. So this deadlock graphs can be recorded, and everything you can do in Profiler in the GUI, you can do automatically with a little SQL code. Yeah, and then again, the SQL code you can have. So the trick is just to demonstrate this, not really. And whatever you click here in Profiler, you just can script the definition for it. And then you see the plain SQL code, what's happening. And this way you can do this magic all automatically with jobs by executing the same code with a job or whatever. Yeah, so here I'm close to such a deadlock situation, yeah, if you remember. So first user sales line, sales header, purchase header. This sales header tried to lock this purchase header, the first block. This is a session that is still up running. So now if this second session tries to lock the sales header of the first session, then I have this crossover block. So a deadlock never can take longer than 5 seconds. Yeah, there are system processes that are searching for these crossover blocks every 5 seconds and will automatically resolve this. So if I do this, 1, 2, 3, 4, 5, 5, 5, 5, 5 seconds, yeah. Okay. So just have to look into the real thing. Yeah, so also these kind of events can be fetched. So I know that there was an event of a deadlock. So this is written to this. But what I did also is in the background, I ran a SQL profile that has an automatic trace. Which was actually catching these graphs. Yeah, I always wonder how many spare time they have in Redmond to create pictures you can move around. Yeah, thank you very much. No, but these graphs can be exported. Yeah, you can pick them up. You can export this, extract event, extract SQL deadlock event. Sorry. So, and if you do that, what you get is an XDL file. An XDL file containing these deadlock graphs. Well, XDL is nothing but just plain ordinary XML. Whenever Internet Explorer tries to start or whatever. Yeah. Hello. Maybe I should close this. So here we go. Yeah, it's XML. So in the easiest case, all you need to do is to maybe just do this. I was hitting I am time. You pick this XML and just drag and drop it to an Excel spreadsheet, open it as an XML table, and then you get it in a clean, structured way. And then again, you can group, you can count, you can make your pivots to see what happens, how often, who is blocking whom, and so on. Yeah, so and then we can start to analyze, making up our minds to investigate this. Well, okay. So this is what I wanted to wrap up, and hopefully filling some interesting tools into your toolbox to get you started to do this troubleshooting. Do we have any questions? So, hang on. So, and if you ask a question that I can answer, you get a T-shirt and a book. So, do we have a microphone or something? Coming. Oh, it's coming. Okay. Gentleman here.
Hi. Thanks for the tips on finding the users causing the locks. Is there not a way that Microsoft can actually pass through that information from the service tier just to SQL Server as a comment?
This is a question we need to ask Microsoft.
It's so feasible though.
I would say the service tier is managing this. The service tier, of course, should know which Navision session is which SQL process. And I just guess, but I think it shouldn't be that tricky to create a kind of virtual table, or maybe better a physical table or something, where we can see which SQL session corresponds to which Navision session. I don't know. So far, I haven't seen anything. So if it's possible, then maybe they keep it secret to keep me busy. Yeah, thank you very much. No, I don't know. So anyway, I give you this. Yeah, but yeah, and this is maybe another challenge we have to face with Navision 2016 as a service, if it's all running in Asia and stuff like this. Because here, with these kind of hosted scenarios, we can establish this kind of blocking, deadlocking detection routines. And this is 0 option in Asia. Yeah, so if you have this as managed service, if there's any blocking, we cannot touch the SQL world. So we will always be screwed. Yeah, we see there is a block because the victim actually will get an error message, but we have no idea what exactly was screwing up, who was causing the block. This was briefly discussed during directions with, I think, was his name Dmitry Chadayev, I think is his last name, who is into this Azure software service magic, but we have no resolution for this. So yeah, I don't know, but I guess no, there is no feature. Any other questions? And I have to apologize, I don't see anything.
The demonstration was in a slightly older version. How is the speed in new version 2016?
I'm sorry, I didn't understand anything.
The demonstration you made was in a slightly older version, not the 2016. How is the speed there?
How the speed is there?
Yeah, is it faster? Is it better?
Oh, this session is recorded, and now you're asking me about something I should answer honestly. No, I didn't test anything on 16 because I learned to wait for update 5.6 or something. Because usually all the first versions screw up a little bit. Yeah. So I give Microsoft a chance to fix this first before I do my comments on this. Okay. Other questions?
Hi.
Oh, you have to come down for the book. So this kind of workout for me. No.
That's okay. Do you know if we raise the compatibility level of the SQL database, it will have a positive influence on performance?
The compatibility level. Yeah. So I reserve this for you. So
yep.
Just great. The compatibility level. You know what it is? Yeah, you know that. Okay. So actually, the compatibility level defines the language the database speaks. So in all the supported scenarios, for Navision, it should always be in a level of the actual server. So if you run Navision 2009 R2 on a SQL 2012, then also the compatibility level should be in this case. Because only then the SQL server could use the full product stack and use all the dynamic management views and all the funny features they are. You only need to have it in a backward compatibility level if you have your own custom programming that is using an old syntax. Or if you have to run some non-supported scenarios. I have some customer running Navision 4.4 Service Pack 3 on a SQL Server 2012, which is not supported at all. And they have to run it in a compatibility level of SQL 2005, because else you get error. So basically, you always should have it in the real server version, which normally also could improve performance in scenarios with Navision 2009 and SQL 2008. There's some difference here. And only if you have your custom programming, then maybe you need to be backward compatible. So.
Okay, I have a question. The repeatable read log, you told us that is a nice feature that is also available in the older versions if you check it in SQL Management Studio. Is there any downside, or do I have to check if it's okay for the customer?
Now you got me, because I tried to come around this. Yes, there's a small print, but it's a very small. The risk of repeatable read is so-called phantom reads. In the old days, with a serializable isolation, a whole range in the clustered index has been locked down. So, and this was accidentally locking records that are not actually part of the result set. So there was a lot of records locked that has nothing to do with the actual query. This is range locking, and I need to draw pictures to make this plausible. So repeatable read means there is no more range lock. Only the existing records in the result sets will be locked. So the range is open, and the advantage is that now we don't have any overlaps anymore, and so the read performance is improved unblocked. The risk is now, since the range is open, of course, something could be inserted into that range. And this is called phantom reads. So that suddenly there's a record that didn't exist before, and so a phantom arises. And this could, of course, have impact for the performance, not actually for performance, but for the data integrity. And this has been discussed with Microsoft a long time in the way of NAV 2013. But actually, the discussion was ended because the Microsoft guys never ever have seen such a phantom read within Navision. I never have seen that, and the end of the discussion is that this is now standard isolation in Navision 7 and up. Yeah, I personally only have seen 2 phantom reads in the past 5 years, so to speak. And in any case, it was just due to stupid programming. Yeah, that was like you have lots of companies, and in the same time, all the companies were writing some data into a master company, some intercompany magic. Yeah, and of course that caused a problem here. But in 99.9999% of all cases, that is okay. Yeah, so the politically correct answer is if you do this repeated read, test it, and if anything weird happens, you have to roll back. But the chances are pretty high that nothing weird happens. Okay, so I'm not sure if you have time for T-shirts. Books are all gone, so probably.
There is only one.
One? Okay, yeah. Oh, next time I bring my sunglasses.
Isn't it kind of risky, perhaps, to add an index in the management studio and behind NAV, so NAV doesn't know about it? So except of the special NAV indexes.
I didn't get the first part of the question.
Is it some kind of risky to add an index in the SQL management studio with NAV not knowing about it?
No, so there is small risk if you obey to some rules. So what we have to, or we must really avoid is any overlap with the naming or with the standard structures of Navision. Navision is naming indexes $0, $1, $2. So never ever in your life create an index named $7. Yeah, because sooner or later this will cause hell. So you need to be up. If you do your own indexing, the indexes should be named totally differently. And of course, this also makes it easier to separate the custom built indexes from the standard indexes. So with all kinds of scripts and code, you can isolate your thing. And then you can't do anything wrong. What you have to learn is to create indexes in an appropriate way. Because these missing index proposals sometimes propose stuff trying to copy tables. Yeah, we have very huge include clauses, and you get proposals where the SQL Server tries to copy item ledger entry 5 times. Yeah, and of course this is rock and roll for read performance, but write performance sucks big time because you virtually insert every record 5 times. Yeah, and this is, if you know these do's and don'ts, you can't do anything wrong. Navision cannot drop these indexes accidentally, apart from some vsift stuff that could be, there's circumstances that can be causing a drop. But this all could be handled. So the risk is minor. Of course, you need to test anything. And all this questions regarding how to manage this, how to document this, how to roll out. Basically, this obeys or implies the same challenges you have with any other add-on you create in .NET. Yeah, if you do a .NET component, you also create it not in Object Designer, you do this in Visual Studio. And also you have to take care about rollout and stuff. So it's the same questions, and there are the same answers or similar answers. So if you like, I have scripts and tools to document this, to roll this out, making sure that Navision cannot drop this. And this way, you can't do any harm, you only can help. Okay, so I guess one more? Another one? Okay. Yeah, there was a slide with Maxstop. I'm thinking a short answer or a long answer? Maybe the medium. Maximum degree of parallelism should always be decreased. The default setting is 0. That could mean that one query kills all the CPU. The rest of the world will set maximum degree of parallelism to the half number of CPU. That's a fair assumption. This does not work with Navision because the Navision queries are too stupid for parallelization. They are just plain simple. There is no point in parallelizing. And what happens with Navision if we have parallelism in the old versions is that we have to suffer from parallel index scans that screw up. So in the old Navisions, old means up to 2009 R2. I recommend, and this is also Microsoft recommendation in some articles, to suppress parallelization by setting max stop to 1. This applies to all the older versions. In the new versions with all the smart queries and other relational commands, I have some good experience in slightly increasing max stop to 2. This is how I set it, and so far it's okay. So hope this answer. Okay, so I think I have stolen enough of your precious coffee break. So I'm here, if you have any questions, I'll be around the whole day. So feel free to contact me here or, of course, maybe offline or wherever. Enjoy this conference and thank you for attending this session. Bye-bye.